Hello everyone, very good morning. Welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not. Yes students, do let me know if I am clearly visible and audible to all of you or not. So that we can start with the session. Shall we? Tell me everyone. So first question, now we are doing questions of chemical bonding, and let's see the first question on your screen, that is the correct statement among 1 to 3 are what? So valence bond theory cannot explain the color exhibited by transition metal element. That is absolutely correct. It cannot exhibit that. Then valence bond theory can predict quantitatively the magnetic properties of transition. Now, magnetic properties were also not identified by VBT, right? Even VBT was not able to tell that. We experimentally told that this is diamagnetic, paramagnetic. From there, you said that, okay, what will be the hybridization? It was able to predict the hybridization from the magnetic data from the experiment. So it was not able to tell you the magnetic data from the hybridization. It was opposite. So that is false. Valence bond theory cannot distinguish ligands as strong or weak. That is absolutely correct. Right. So we can say true statements are 1 and 3 are the true statements. So D will be the correct answer here. Right, everybody? D is going to be the correct answer here. Right. Next is give the order of dipole moment of the following compound. So these three compounds are given to you. You have to tell me the dipole moments of these compounds here, right? Dipole moments of these compound here. So if you talk about dipole moment always goes from positive to negative. So this is going from carbon to this positive. This is going from positive to negative. That is over here. It is going like this, right? There it is carbon. This is carbon, right? It is going like this. So it is getting added up. Here it is going like this. It is going like this. So there is some subtraction here. Here it is going like this. It is going like this. It is more subtraction here because the angle is less, right? Okay, so we can see that from here that first one, the addition is more there, right? That means the totality of the dipole moment is more. Then you have second, then you have third, right? So answer will be B is the correct answer here. So answer will be B is the correct answer here. Right, everybody? Do let me know. Very good, Shrey, very good. Achha, next is, if you see the next one, the correct order of bond angles of the following compound species are what? Now, first you will have to see the hybridization. If I talk about the hybridization of CO2, it is sp, because it is C double bond O. This is sp hybridization, so it has 180-degree bond angle, right? Then you have NH3, it has 1 lone pair, and then you have water. Water has 2 lone pairs. Now it should be 104, but because of lone pair repulsion, lone pair bond pair repulsion, it will increase, the bond angle will increase. So what will happen here? The bond angle will go up to 107 and here it will go up to 109. So it is going to increase here. Here because of 2 lone pair, here because of 1 lone pair. What about this one? What about NH4? Now there is no lone pair. It has 1 lone pair. It has, it has 0 lone pair, 1 lone pair, it has 2 lone pair. Now remember one thing. Firstly, check the hybridization of all of them is sp3, right? Because it is tetrahedral, na? It has 4 sigma, it has 3 sigma plus 1 lone pair, it has 2 sigma plus 2 lone pair. So hybridization is sp3 in all the cases. Now we know that if you talk about hybridization, sp has maximum, then sp2, then sp3. That is the angle. So CO2 will have maximum, right? So this is ruled out. Then after that, more is the number of lone pair, more will be the repulsion, lesser will be the angle. Because of those repulsion, angle will decrease. So what exactly happens? If I say this is tetrahedral, what will happen if there are repulsion, this repulsion, this repulsion, this repulsion? What will happen? This angle is going to decrease here because of the repulsions, right? So we can say lone pair with 0 lone pair repulsion is less, so that means bond angle is more. So more the lone pairs, more will be the repulsion, less will be the bond angle. So you can say that lone pair is inversely proportional to bond angle. That is how you have B as the correct answer here. Right, everybody? Tell me. Clear? Clear? Clear, everyone? Then you have next one, that is the sum of lone pair of electrons on each center metal atom. Wait a minute, like just my body in the morning behaves something very differently. The sum of the number of lone pairs of electrons on each centimetal atom in the following species are what? So here you have to see the number of lone pairs, okay? So let's see how do I tell that. So you have Te, Br, 6, 2 negative. Acha, tell me firstly, what do you mean by Te here? What is sterilium? That belongs to उससे टेपो, that means it belongs to group number 16, so it has 6 valence electrons. Out of those 6 valence electrons, you're also adding 2 electrons of this negative, right, because of that. And here you are occupying those 6 bond pairs, so that will be subtracted. So here you will have 2. That means 2 electrons mean 1 lone pair. Okay. Now let's talk about the second one, that is BrF2 positive. See, how do we write it? Bromine belongs to group number 17, so 7 outermost electrons. Whenever you have plus, that means you're subtracting that many amount of electrons. So plus 1 means minus 1. And 2 electrons are already occupied, already busy in forming bonds. So 7 minus 3 is 4. So it is 4. 4 means 2 lone pair, right? Achha, now third one is XCF3, right? XCF3 negative. Now tell me, how do I answer it? Xenon belongs to group number 18, right? Yes, very good. Group number 18. So it is 8 outermost electrons. Plus 1. For negative you add it. This is minus 3. 3 bond pairs are there. So it was 9 minus 3 is 6. 6 means 3 lone pairs. So now total number of lone pair is 2 plus 1 plus 3. That is 6. So answer is 6 is the correct answer here. So D will be the correct answer here. Tell me, is that clear, everybody? Is that clear? Any problem there? So D is the correct answer here. Is there any problem, everyone? Is there any problem? Do let me know in the chat box. Is there any problem? Do let me know in the chat box. You can see the structures also. right? Acha, ma'am, why this is one lone pair? So I'll tell you, this has one lone pair and 6 sigma bonds. So 6 sigma plus 1 lone pair means 7. That means sp3d, this is going to be, if you see, this is going to be sp3d3. That is going to have what thing? That is going to be bipyramidal, na? 2 pyramids will be there. 7 bonds will be there and 1 lone pair will be there. Okay? 1, 2, 3, 4 and this is 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 will be there in total. If you talk about this one, here it was 4. How many bonds were there? 2 bonds and 2 lone pair. So 2 bonds plus 2 lone pair is 4. Right? That is why it is tetrahedral, and that is 3 bonds plus 3 lone pair. If you have 3 bonds plus 3 lone pair, that is 6. That is octahedral shape. Okay? Geometry. Right? That's how you can tell all of that. Acha, now let's talk about this thing here. Next question is, identify the species having only one pi bond, maximum number of canonical forms in the following, right? Okay? Yes, steric number. Yes, yes, yes. Kalyani, that is the steric number. Okay? Yes. Beta, that is steric number only na, that I have written here. Number of bond pair plus lone pair, that is the steric number na. Okay? Yes. Right? Okay, see now this thing. If you see, they identify the species having pi bond. See, if you talk about SO2, it has S double bond O, double bond O, double bond O. This structure is there. SO2 is this kind of structure, right? This kind of structure is there in SO2. That I'll tell you that how we draw this structure. As of now, just see that this structure is there. Now, if you talk about CO3 2 negative and O2, acha, there is O2 here. O2 also has O double bond only, right? So, maximum canonical structure. See, first thing is pi bond is there, one pi bond is here, and here you have one pi bond. That is C double bond O, O negative. This is double bond, this is also O negative, right? This is the canonical structure. This is the carbonate ion. Now, this can have the resonating structure, but others cannot have the resonating structure. So, answer is A only the correct answer. Why? Because it can form the canonical structures like this. C double bond O, this is O negative, this is O negative. It will give rise to double bond can be here. It is O negative, it is O negative. Or double bond can be here. It is O negative and this is O negative. Right? Okay. Right, everybody? So, answer is going to be A is the correct answer here. Right? Okay, now next is, which of the following has maximum number of lone pair associated with xenon? Now, let's see how to find it out. Lone pair, how do you find it? Xenon belongs to group number 18. That means 8 outermost electrons, right? So always remember 8 outermost electrons, and always this is forming a multiple bond with oxygen. So you have xenon, it will be forming multiple bond with oxygen. That means 1, 2, 3, 4, 5, 6 bonds will be subtracted here. That means you will have 2, that means 1 lone pair will be there, okay? When I have 1 lone pair, that means in all, if you're calculating, let's say 1 lone pair plus 3, how many sigma bonds? 3 sigma bonds. Total bond pairs are 6, including pi bonds, so sigma bonds are 3 only, right? So that means 4, that means it is going to be a tetrahedral structure, right? Second is this one, you have 8, this is -4, because with fluorine it forms only sigma bond, simple bond. right? This is 4, that means 2 lone pair, right? Now they are asking to find maximum number of lone pair. This is 8 minus 6, that means 2, that is 1 lone pair. Okay? This is 8 minus 2, that is 6, that is 3 lone pairs. So maximum lone pair are present in case of XeF2. If you see what is the structure, what is the shape or geometry here, this is tetrahedral, this is the steric number, you can say this is tetrahedral, okay, with 1 lone pair. This is 2 bond pair, sigma is 4, lone pair is 2, that is 6. This is octahedral. Okay, this is I am talking about geometries, right? This is 6 plus 1 lone pair, that is 7, that is pentagonal bipyramidal, right? That is the geometry, pentagonal bipyramidal, okay. Next is you have 2 sigma and you have 3 lone pair, that is 5, that defines for trigonal bipyramidal, okay. Now how to place the lone pairs here, you can see this over here, how to place the lone pairs here. If you see this, XeF4 is in tetrahedral, so there will be 1 lone pair. So whenever you have a tetrahedral geometry, this particular one will be your lone pair. Let's say this is the lone pair, these are the bond pairs. So lone pair, we don't consider it in the shape, right? So that's why it is pyramidal shape. The shape is pyramidal here. If you talk about octahedral, it looks like this. Here you have 2 lone pairs. One is this and one is this, other are bond pairs. Okay, so that's why it will have square planar. It will have square planar. So you can say this is a pyramidal shape. Okay, because that also they can ask you, this is square planar. This is square planar. Shape is different. Shape we don't include lone pair. Now in this case, XeF2 I told you by trigonal bipyramidal, that is this kind of situation. Now lone pair are always on the equatorial position, that means here and here. So here you will have a lone pair, here you will have a lone pair. If I take out this, it will be a T shape, right? So that is about the lone pair here. It will always, 3 lone pairs are there, so it will be on the equatorial position, 1, 2, 3, and it will be a linear shape here, right? It will be a linear shape here. What about this one? Here in this case, you have a lone pair here, and this is, ignore the lone pair, this whole is distorted octahedral. So you can write distorted octahedral. Okay, tell me, is that clear? Is that clear? sp3 do, if the steric number here was coming out to be 4, here steric number was 3, 4, 6, 7, here it was, wait a minute, no, this was 6, right? This was 7 and this was 5, and that's how you have these hybridizations, right? Okay, tell me. Yes, everybody, tell me. Right, next is match the list 1 with list 2. So this is list 1. If you see this over here, let's match the list 1 with list 2. List 1 is SF4, so let's talk about SF4 first, right? See how I am calculating, and you have to do it the same way, because this is a for sure question that will be asked to you regarding your shapes. First is SF4. Sulfur has total how many electrons? Tell me everyone, sulfur has total how many electrons? Okay? Okay. Magnetic properties, I have already done it in coordination. Okay. Yes. SF4. Sulfur belongs to group number 16, 6 outermost, minus 4 are already occupied in bonding. It will be 2, that is 1 lone pair. So total sigma is 4 plus 1 lone pair, it is 5. So it will be sp3d. Okay, you can see sp3d. That means A is 3. A is 3, that is here and here. These two are already eliminated. Then there is IF5, right? IF5. Okay? IF5. So how do you write it? IF5 also you can directly, I think with IF5 only you will get the answer if you see. Right? If you tell IF5, you will get the answer directly. Right? See. Then also I'll tell you the steric number method also. Right? IF5 you have how many lone pair? This is 7 outermost electrons minus 5, that is 2, that is 1 lone pair. So 5 is the sigma, 1 is the lone pair, it is 6. That means sp3d2. Right? That means sp3d2 is this one. So it is 1. So B is 1, so answer will be D as the correct answer. But ma'am, how do you calculate this NO2 and NH4 positive? See, you can calculate it anyway, right? So you can calculate it from the Z value as well. Z is nothing but it is half of the valence electrons that you have, right? Valence electrons of, let's say I am calculating for NH4 positive. Valence electrons of nitrogen are 5. Okay. Then number of monovalent atoms are 4, that will be added here, right? Then if you have any so number of monovalent atoms will be added, yes. Then if you have any cation, that will be subtracted, right? So it is 5, 6, 7, 8, 9, 9 minus 1, that is 8. 8 by 2 is 4. So that is sp3. Okay? This is from the formula, right? This is from the formula you can calculate, right? Okay? So either ways you can calculate. This D is nothing but 4, that is sp3, right? If you talk about C, that is NO2 positive, that is sp, right? And that's how you calculate this, right, everybody? Do let me know in the chat box if that is clear to all of you or not. Right, everyone? Do let me know if that is clear to all of you or not. Right? Okay? Understood? Acha, next question is what? Total number of molecules with pyramidal shape are what? So these are all the different molecules. Pyramidal shape, you need to have pyramidal shape. That means, let's talk about, see, this will have tetrahedral shape. This though we know. This is Cl, ClF3 if I talk about. Chlorine is 7 outermost electrons, right? Now in this case, seven outermost electrons you have, then minus 3, that is going to be 4, that is 2 lone pair. So what you have, 3 sigma plus 2 lone pair, that is 5, that is sp3d2. So 2 lone pair. So what should be the shape? 2 lone pairs means here. So it is going to be a T shape. Okay, it is going to be a T shape. So that is already ruled out. That is already ruled out. This is also not pyramidal. This is also not pyramidal. Right? What about SO3? So SO3 is quite famous. Right? But still, if you want to write sulfur, SO3. SO3, sulfur belongs to group number 16. That means 6 outermost electron. Oxygen always form multiple bonds. So it is 6 minus 6. So total 6 bond pairs are there, 0 lone pair you have. Now if you calculate, sigma is 6, sigma is how many sigma? 3 plus there is 0 lone pair, it is 3, that is sp2. That is nothing but it is this kind of situation. 120 degree angle, na? This kind of situation. That is also not, this is trigonal planar. This is not pyramidal, right? So you can say here the shape is trigonal planar. That is the shape, okay? Trigonal planar. Very good. XeO3 is pyramidal, very good, right? So this is also ruled out, right? PCl3, this is also a very famous compound. Let's calculate PCl3. Phosphorus belongs to group number which? 15, right? 5 outermost electrons, 3 are occupied, that means 2, that means 1 lone pair, right? 1 lone pair is there. Sigma is 3 and lone pair is 1, so it will be 4, that means sp3 is the, this can be, right? Now, in this case, you have 1 lone pair. So, in the tetrahedral, when one of them is lone pair, it becomes pyramid, na? Right? So, that is pyramidal, right? Okay? So, you can see this one is pyramidal. So, answer will be this one is correct. So, this one will be counted as pyramidal. What about XeO3? You will write it, this is pyramidal. Pyramidal. Okay? This is pyramidal. I am not drawing the shapes here, already I have drawn it here, right? Okay, so if you see, this is pyramidal, right? This is first that we have calculated as pyramidal. Now let's talk about others. You have XeO3, right? I'll calculate each of them, right? You must know how to answer that. XeO3. Xenon belongs to group number 18, so 8 outermost, and it has 3 multiple bonds. Okay? So that means total 6, it will be 2, that is 1 lone pair. Sigma is 3, lone pair is 1, it is 4. So whenever there is 3 sigma, 1 lone pair, it is always pyramidal, right? Here hybridization is sp3 with 1 lone pair, that is obviously going to be pyramidal. So you have, till now you have 2 of them. This, wait a minute, why I have not calculated NH3? Oh, big mistake I have done. Oh, I think I'm so in need right now that I forgot. See, NH3 is pyramidal only, it has sp3. So if you calculate this, we all know this is sp3, and I was supposed to write tick here, I wrote wrong there. Till now we have these 3. So how NH3? It is belonging to group number 15, that is 5, minus 3, that is 2, that is 1 lone pair, right? So it has 3 sigma plus 1 lone pair, that is 4, that is sp3. Again it will be pyramidal, okay? Right? Again it will be pyramidal. So you have till now 3 of them. Pyramidal, okay? Next is which one? Yes, students. BCl3. This is not pyramidal. BCl3 is actually square. This is trigonal planar. Let's see. BCl3. This belongs to group number 13. That means 3 minus 3. It means 0 lone pair. Total 3 sigma you have. That means it will be 3 sigma, there is 0 lone pair, it means 3, it will be sp2, so that is going to be square planar, right? It is going to be square planar, right? Pyramidal is possible when you have sp3 hybridization and there is 1 lone pair, okay? Now, rest of it, let's see, 2, 3, I think you will be left with, right? In this you can mark cross here as well. Now last 2, let's see, that is ClO3 negative, let's see that, okay? ClO3 negative. Chlorine belongs to group number 17, that means write 7 here. Chlorine always form multiple bonds, but there will be 1 single bond because there is this negative here. So, or you can just simply say this has this one electron will be added here, right? And you will 1 2 3 4 5 sigma bonds are there, 5 bond are there, so that will be subtracted. But if you're adding it, right, to calculate the number of lone pair, if you're adding it, I will not, then I'll consider it as a double bond only, because now why to use that much brain? Hai na? So 3 oxygens you have, multiple bond and 1 negative means that will be added. So it will be 8 minus 6. Okay? That is 2, that is 1 lone pair. Total sigma bonds if you see are 3. Total lone pair is 1, that is 4, that is sp3 only, right? So definitely it is going to be pyramidal. But here it will be like this. Cl, this is lone pair, this is O negative, double bond O, double bond O. Right? Okay? That will be the situation. Right? Acha, tell me next thing here. Last one. So this is also correct. 1, 2, 3, 4. SO3, 2 negative. So you have SO3, 2 negative. Sulfur has group number 16. So it is 6 plus 2 electrons are added here because of minus 2. It has with oxygen, 3 oxygen. It has total 6 bond pairs, so it is minus 6, so it is 6 minus 6, it is 2, that is 1 lone pair, right? Sigma bond is 3, 1 lone pair you have, total 4, that means sp3 with 1 lone pair. Again this is pyramidal, okay? Here structure will be like this, S, this is a lone pair, this will be O negative, double bond O. Okay, tell me. Yes, understood now how it is? Option D, very good. How it is coming out to be 5, right? So answer is D is the correct answer here. Right, everybody? Tell me in the chat box, right? Okay. And also do hit the like button, guys, right? So much efforts. For me, though, it takes so much efforts to wake up in the morning. I'm totally dead at this point. So, total number of molecules, acha, this we have done. Now, let's see from MOT how they ask you the questions, right? Which one of the following order of energies of molecular orbital of N2 is correct? Now remember one thing, whenever you have less than or equals to 14 and whenever you have more than 14, that has a different electronic configuration. If you see this over here, right? So directly see this over here. If you have less than or equals to 14, this part will be same. This part will not change. This part is same. Less than or equals to 14, you will have 2, 1, 2, 1. Here you will have 1, 2, 2, 1. That is the only difference that you will have. Okay? Here this is 2, P and X equal. That is 2. Then 1. Then again you have 2, then again you have 1. These are bonding, these are anti-bonding. Here you have 1, 2. So here you have firstly Z, then you have X and P equal, then you have again X and P anti-bonding equal, then you have Z anti-bonding. So it is 1, 2, 2, 1. Right? Okay. So after filling this, for N2 that is equals to 14, it will be 2, 1, 2, 1. So it will be this 2, 1, right? So simple thing is, how do you write this overall here? N2 is equals to 14 electrons, okay? How do you write it? 14 electrons are there. Out of these 14 electrons, 8 will be occupied already in the sigma 1s, sigma star 1s. So you can fill 2, 3, 4, 5, 6, wait a minute, even 1s will be there, na? So it is sigma 1s2, sigma star 1s2, then sigma 2s, sigma star 2s, that will be there. It will be total 8 electrons will gone. So 14 minus 8 electrons, you are left with 4, 5, 6 electrons. Now here it is 2, 1, 2, 1. So how do you fill this 6 electrons? 1, 2, 3, 4, 5, 6. So that's how you will write this particular part here, that in equal you have 2 electrons. So sigma pi 2px is 2, pi 2py is 2 electrons there, and sigma 2pz also has 2 electrons. Okay, that's how you fill this, and that's how you got your answer as A as the correct answer. Now we will see more questions on this. Which of the following molecules does not contain unpaired electrons? Achha, which of the following is not paramagnetic? Okay, so let's understand that. Firstly, I'll calculate it for N2. See, N2 positive. N2 is 14 minus 1, that is 13 electron, N2 positive, right? Positive means you'll have to subtract it. Now, out of 13, you will subtract 8 electron, that is in sigma 1s, sigma 2s, sigma star 1s, sigma star 2s. So 13 minus 8 will be 3, 4, 5, 5 electrons you have to fill. Now it follows 2, 1, 2, 1, because here it is equals to, it is less than 14 electrons. So it will be 2, 1, 2, 1. It will be 2, 1, 2, 1. So here you will write it as 1, 2, right? I'll just write this as 5 electron, 1, 2, 3, 4, and this is 5. So there is one unpaired electron here. Does not contain, this though is containing unpaired electron. What about O2? O2 though we all know this is paramagnetic. That's how this theory was designed. But still, if you want to calculate O2, O2 is having total 8 to 16 electrons, right? Okay. Out of those 16 electrons, I'll subtract 8 for KK star. 8 is subtracted and you will be left with 8 electrons. And here you follow 1, 2, 2, 1 because it is more than 14, right? So it will be 1, 2, 2, 1. Okay. Now you fill the electrons, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. You can see 2 unpaired electrons here. This also has unpaired electron. Achha, now when you see for O2 2 negative, that is interesting part. When you see for O2 2 negative, O2 2 negative, it is 16 plus 2, 18 electrons. In case of 18 electrons, see, I'll just give you the, there is direct trick as well, but let's see how to calculate. If you see, this is 18 electrons. In case of 18 electrons, what you have? 18 minus 8, that is 10 electrons you have to fill here. That is 1, 2, 2, 1. 1, 2, 2, 1. So this is 1, 2, 2, 1. So in this case, what you have? Fill 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So what is there in these 10 electrons? What you can see, it is having no unpaired electrons. So answer will be C is the correct answer. I'll give you a trick also in the end. Right? Then there is B2. Boron is what? Hydrogen, helium, lithium, beryllium, boron, 5, 5 to 10. Okay? 10 electrons, now you can't, out of 10 subtract 8, that will be in KK star, you will be left with 2. And here, because it is less than 14, you will follow 2, 1, 2, 1. So it is 2, 1, 2, 1. Right? So it will be 2 electrons here. Right? Again, it will be para. Okay? Achha, now shall I give you the trick here? You don't have to do all of this. Tell me everyone, what is the trick? Within seconds, you'll be able to answer this. For the trick, just remember one thing. For the trick, guys, just remember one thing. And what is that thing? That whenever you have odd, it will have unpaired electron. Whenever you have odd, it will have unpaired electron, it will be paramagnetic. Even number will be diamagnetic. But except B2 and O2. B2 which has 10 electrons, it is even but still it is paramagnetic. O2 which has 16 electron, it is even but still it is paramagnetic. But otherwise even will always be diamagnetic. ठीक है? Tell me. Okay? Yes? Tell me everybody. Is that clear? So from there you can see this has 14 minus 3, that 14 minus 1, that is 13 electron. This has 16, that has 16 plus 2, 18. This is 10 electrons. So these two are definitely para because they are under the exception, and we know that odd will also be para. So you are left with this even, that will be di. So you can directly answer from there. Right everybody? Tell me. From the trick as well you can directly answer. Right? I have also told you how to solve it. I have also told you the direct trick that you have for this particular case. Right everybody? Okay? This you must remember. Okay? This you must remember. Then let's talk about the next one, that is, consider the given species that is given to you. Which one of these will have highest bond order? Now bond order trick also directly remember that for 14 it is 3. If you go down it is 15, 16, 17, 18. That will decrease by 0.5. This is 2, this is 1.5, this is 1. If you go here 13, 12, 11 and 10, here also it will decrease by 0.5. So it is 2.5 to 1.51. Okay? Understood? So if you see this here, consider the given species. NO, nitrogen is 7, oxygen is 8. So it is 7 to 14, it is 15 electrons. Carbon is, I am giving you directly from the trick. Okay? So carbon is 6, nitrogen is 7, minus 1, that is going, minus 1 means it will be added here. So 7 to 14, right? This is 6, this is carbon is 6, nitrogen is 7, 6 to 12, 13, right? Then what you have here, Cn, that is 6 plus 7 minus 1, that is 12. Now out of this 14 has maximum bond order, that is 3. Okay, 15 will be 2.5. Okay, 13 will again be 2.5. If you see it from the trick, 12 will be 2. Okay, that's how you can directly answer. Tell me guys, is that clear how you can directly? Acha, tell me. If ma'am, we don't want to answer directly, ma'am, we want to, ma'am, go through the full method, ma'am, then what we will do? See, then I told you how to write the electronic configuration from the number of electrons, right? After that, just do bond order is equals to bonding minus anti-bonding by 2. That is the answer. For example, here it is bonding is, these two will cancel eventually. This will be 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 6 minus anti-bonding is 1 divided by 2, that is 5 by 2, that is 2.5. Okay, because this I am not including only, because they are eventually cancelling. This also eventually is cancelling. Anti-bonding is nothing, so it is 6 minus 0 by 2, that is 3. Okay, here also this is eventually cancelling only. This is 4, 5 minus 2 by 5 minus 1 by 2, that is 2. 5 minus 1 by 2, that is 4. Wait a minute, 1, 2, 3, 4, 5. Okay. 5 minus 0 na, 0 will be there. Anti-bonding is nothing. 5 minus 0 by 2, that is 2.5. Okay. Here again, if you calculate this, this will be 4 minus 0 by 2, that is 2. So it's totally your choice how you want to calculate it. Some students, they put this values as well, but I don't use that because it is already equal. So they will be always sigma 1s, sigma star 1s, sigma 2s, sigma star 2s will cancel only, right? For obviously more than 8 electrons, right? But why to do this much? You should know how to do it, but you can directly answer it from this trick, right? Okay. Let's see the last question, guys. Last question on your screen you have. Last question, everybody. Let's see if you can answer. That is the relationship between the dissociation energy of N2 and N2 positive, right? N2 is what and N2 positive is what? Now see, if you talk about bond order, more is the bond order, less will be the bond length. Okay? Bond order, okay, like for nitrogen it is 3, so its bond length is smaller. More is the bond order, bond length is inversely proportional to the bond order. Firstly, to remember this thing. And that is, more is the bond order, more will be the bond strength. It is directly proportional to bond strength. Now, if bond strength is high, then bond dissociation energy will also be high. So that means indirectly they want to know which has more bond order. Tell me which has more bond order. It's such a simple question, right? This is 7 plus 7. Now, if you don't know this thing, if you don't know this, if you don't know the trick, then obviously not a simple question, because if you know, it is easy only. 7 plus 7, 14 minus 1, that is 13. 14 always has 3 bond order, 13 has 2.5. So, more the bond order, more will be the bond dissociation energy. So, we can say bond dissociation energy of N2 is greater than N2 positive. So, answer will be C is the correct answer here. Okay? Tell me. Answer will be C is the correct answer here. Do you got it now? How I am answering this? Directly from the trick I am answering. Okay? Try to save your time. Right? You definitely should know. That's why first question that I did, I solved it properly. Right? Paramagnetic, diamagnetic. But after that, I told you the trick for para-di also, for bond order also. Here you can answer it directly from the trick. So answer it, right? Why to waste our time? Right, everybody? Okay? Chalo. So that's it for today. And guys, the PDF will be provided to you in the description box. You can check that in the description box over there. And all the best for your day. And yes, now do let me know that have you watched biomolecules, aldehyde ketones and amines or not, and what else you want for your JEE 2026 attempt 1. Do let me know in the comment section regarding chemistry what you want, right? And the PDF will be provided in the description box and also on the Telegram, right? Okay, chalo. Okay guys, then bye bye, take care, bye bye.